we present a new rendering technique called Implicit Brushes that produces coherent stylized lines from animated 3D scenes in real time. Most existing line rendering techniques focus on depicting surface features extracted in object space. Even with static objects, these methods are prone to line clutter issues. This is because features are extracted at a single scale in pre-process. Our first contribution is to extend most common surface features to a screen space definition, which permits to extract new features at each frame. As a result, lines split and merge naturally to depict relevant features at the current scale. Such changes of line topology make their stylization difficult, especially with stroke-based techniques. These methods suffer from popping artifacts due to necessary changes in stroke parametrization. Our second contribution is to provide a stylization technique adapted to dynamically extracted surface features. It is based on an implicit convolution technique that applies brush footprints anywhere near a surface feature. We now briefly explain our approach, beginning with the extraction of surface features. We illustrate it here with surface valleys. We first compute minimum curvature, shown here as a height field in grayscale. The associated minimum curvature direction at each pixel provides a direction field that we display using line integral convolution, with directional singularities shown in red. Both the height and direction fields are used to fit a per pixel feature profile. Here we show profile intensity. Observe how profiles are naturally updated when the object is zoomed out. We also take advantage of the screen space definition to select fine or coarse features. The second stage of our approach allows users to depict lines in a variety of styles. It consists in convoluting pixels close enough to a sharp enough feature with a brush footprint. If we take a direct weight function, then lines correspond to binary feature skeletons. It is more interesting to correlate weight to feature profile properties though. Examples include binary thin lines depicting features with high enough profile intensity, smooth thin lines depicting feature intensity variations, and blurry lines depicting profile curvature. The choice of brush footprint has a direct impact on line style. We also allow footprints to be transformed based on feature profile characteristics. It is also interesting to add an amount of perturbation. We use coherent noise techniques to modulate either weight or brush functions. It creates a variety of stylization effects. Our method has some limitations. Lines exhibit artifacts due to the sampling of normals. It can be attenuated by applying more anisotropic diffusion iterations. Some effects specific to stroke-based approaches cannot be obtained exactly in our system. For instance, dotted lines require a 2D parametrization. Our method is well adapted to scientific illustration. Surface inflections combined with mean curvature shading convey efficiently relief details of archaeological objects at various scales. In addition, stylistic variations permit to depict features of varying sharpness by using lines only. Since the method works in screen space, it works equally well on fluid simulations. Here we demonstrate our system applied to a simple dynamic water simulation. The performance and flexibility of our technique make it suited to video games. It works with deformable models without any pre-process. Therefore, it can be directly applied to different models without requiring user intervention. Features found in normal maps are depicted without any modification to the algorithm. The method thus works well in complex scenes composed of normal mapped objects. Finally, the method can be used as an offline module in compositing pipelines. If normal and depth images are available, then the method may be used with different parameters to combine different features. Here we combine ridges, valleys, and occluding contours, each rendered in their own style. With simple color videos, the method can still be applied on luminance, for instance, although occluding contours are not available. The resulting lines may either be rendered alone, or they may be overlaid on top of the original image. Thank you for your attention.